Okay, thank you very much. Right, so I'll set a bit of context here, because now we're going to talk about trucks and heavy fleet and moving dirt. So we're getting into the serious stuff about how we can use hydrogen. We saw Minister Alana this morning referenced the CSIRO cost curve and made the point that we're not in pixie land. There's always a few sceptical members around, but perhaps we'll start there. And perhaps I think for context, let's just pitch ourselves if we can. It's a bit cool in this room, but perhaps we're in Kalgoorlie right now, or up in the Pilbara. And let's talk about, if we can, some of the barriers to hydrogen for heavy vehicle fleet and their applications, infrastructure and economics. And I think perhaps Cohen and Alfred, if you could perhaps focus on those aspects around the infrastructure and economics, and then safety standards and vehicle conversions, Jan and Peter, perhaps you could touch on that. So perhaps we'll just head around and
sure.
You start.
Okay, well, thanks very much. I'm Alfred Wong with Ballard Power, the Managing Director for the APAC region. Maybe just a brief introduction. Unlike many of you, I really know nothing about mining, but I've been in the hydrogen fuel cell industry for 19 years now, and at Ballard we have witnessed the introduction of the technology in many different sectors. So 2007 was really the first time we introduced forklift trucks. Now it's really 15,000 trucks running globally. We're really the first in 2010 to introduce a mobile PEM fuel cell generator running on, that was a 1 megawatt project that we did, running on hydrogen. So just kind of backing up, it's, we've seen over the time that hydrogen and fuel cells getting introduced in new markets. So we're really excited that we're here to talk about mining. Now in terms of the barriers, to us, heavy-duty vehicles we really see heavy-duty vehicles as a real sweet spot for the use of hydrogen. So when we compare other zero-emission technologies, really primarily batteries, hydrogen fuel cells are really, it really offers a real value proposition in heavy payload and also in long range. And I think that's where, really in mining, you're moving very heavy equipment. So, you want to look at electrification and zero emission, you're not going to be able to get that out of batteries. So it really offers a real compelling proposition, and it also offers central refueling. So another point that we think it's going to really help. Now, to overcome the barriers, we think that a lot of it's going to be from scale. We've seen the application of fuel cells and other applications outside of mining, and that's really helping to address the cost side of things. And I think we talked a little bit earlier, I think there's mention about TCO. It's really about getting the fuel costs down, because the fuel is really a lot of the component of the cost. And I think the fall of the renewables power generation and how much lower it is now to generate electricity with renewables, which you can use to power electrolyzers to generate hydrogen, is really going to change the cost equation. So some of these cost barriers or these barriers to entry, I think, are going to get removed through both scale and application in renewables.
Thank you very much. And perhaps we can focus on, obviously all miners now have got a fairly heavy installed infrastructure around their current fuel source. What do you see as the barriers to the infrastructure?
The current ones, or the diesel one? I think
how do we see we're switching out?
How do you see? Okay, perfect. Maybe just a quick introduction as well. So my name is Koen Lenke, part of the NGVU Hydrogen, the business unit for hydrogen. Why a business unit? Because we believe it's a business, and I think today is a good example of that we're going to this direction. We are focusing on the mines because we see that the mines are crucial within the energy transition. Because if the minerals that we will use for new technologies that we want to do the energy transition with are not green, then of course none of it will make sense. So coming back to your question, it's the chicken and the egg problem. So today we don't have the infrastructure, we don't have the trucks. So how do we get there? And I think this is one of the big challenges. We have to do a collaboration. We have to create awareness because the technology is ready. We just need to put the pieces together at scale, both for the truck. So the fuel cell technology is there. We have 100 kilowatt stacks. We are going for 200 kilowatts. For this truck, we need a 1 megawatt system, which can actually be built with the existing stack technology we have today. For the hydrogen infrastructure, we have the electrolyzers, which are at the right size. It's a modular technology, so it can be built with a stepwise approach. As was said before, to de-risk, to make it bankable. So I think in this way, it's just a matter of collaborating and start building up the system stepwise approach. And it's very important to have scale. Scale is of the essence.
Okay, thank you. And let's start talking about, from the miner's perspective, some of the, where do we see across the industry, do we see hydrogen being transported, or do we see electrolyzers being built in every mine site?
Maybe just building briefly on what Andrew and Kuhn was saying. When we look at, and I think we said earlier on that there's a lot of movement happening at the moment and interest in hydrogen. If we look at a number of the countries where that has actually been the case, and actually hydrogen being deployed, whether it's in California, in Japan, in Germany, etc., they've always had that chicken egg. They're facing that chicken egg problem, and in terms of what comes first, the vehicle or the infrastructure. And the beauty of the opportunity in mining is that in one place you can actually you have the opportunity to deploy kind of what is currently on the road, even in just a few trucks, the entire fuel cell capacity of what is on the road in California at the moment. And that has come on there over years. So you don't have this needs to come first, that needs to come first, but actually because you can do it at the same time in the same place at scale, relatively quickly, provided all those challenges are overcome. In terms of your question, I don't know what we see more. I think you've seen how we're looking at it at the moment, and again, that will make sense in the individual cases. Other cases in other jurisdictions and may look different. You come into question of, I don't know, some mines are operated at 4,000 meter altitude versus being at sea level, or being so you've. I think there isn't the one approach towards that yet. What I do think, though, is that a lot of mining companies are definitely showing a lot of interest, right? But as we said earlier, it's early days, and we need to figure out how that works best. And again, that's not something we're going to be doing by ourselves, but we need to talk to people who actually have worked in this space for a long time, because we may know mining, but not so much about hydrogen fuel cells. And the hydrogen fuel cell guys may know a lot about that, but not so much about mining yet.
Thanks, Jan. And for me, I was quite interested in your comments about the challenges around safety and introducing the technology. Perhaps you could explore a bit about the vehicle conversion. We talked a little bit about that and scaling it up, but then safety standards and actually getting it into an operating environment.
So from a safety perspective, like I said to you, our focus was around the metal hydride technology. So the development around that technology in particular requires enormous safety attention. Especially when you're manufacturing the cylinders in which you put your rare earth materials or your recipe for your metal hydride. Because if you don't operate that correctly and it's not designed correctly, they can leak through, it can have exposure and result in explosion. So what we try to do is look at what standards are available, compare it with international standards, and then adopt what we consider to be the better of the two moving forward. So that was from a design perspective. From an operation perspective, your fuel cell manufacturers will give you information in terms of what is safe and what is required. From a maintenance and operation perspective, what you can and can't do, and that's the reason why we have to get trained technicians out. They take 3-4 weeks to sort out. So there is information that's out there, and I think Australia is doing the right thing by saying, if we don't have it, let's adopt what is there, and we've done exactly the same thing in our approach. But the one thing that does keep me up at night is, how do we then define to what point, especially with me, prototype testing, do you run this piece of equipment? Your forklift manufacturer gives you a certain indication, your fuel cell manufacturer gives you an idea, the metal hydride OEM tells you something else. But how do you collectively run the entire system safely? What is that point? You can't run it to a point of failure. We have equipment in the plant. I have a pump. I run it till it's completely run out, and I have a spare that I take and I put in. It puts production off for 5-10 minutes while I do that changeover. But if you're looking at a forklift, if I run into a point of failure, it could be catastrophic, there could be loss of life. That's not something that we want. And I struggle to find standards and criteria that's out there that says, this is what we should be working towards. At this particular point, you can no longer run this particular unit. It's no longer safe for your operation. Or this is the overall that's required to get it back to safety. It all differs from one to the next. So for me, that still is an area of concern.
Thank you. Perhaps let's move on to the question here is, how is the fuel and equipment suppliers approaching hydrogen for mining vehicles and trains? So the OEMs, the Komatsu's, Caterpillars, Hitachis and GE, and of course the fuel suppliers that are providing infrastructure.
Sure. Yeah. From a product and a solution perspective on the hydrogen fuel cell side, we really see, we see fuel cells as a power source, and we've been putting fuel cells into bus, into trucks, into rail, into marine. So moving into mining vehicles, there is additional requirements, but it's really not all that different. We're talking about powertrain, electric powertrain. So over the last little while, we have had yielded a lot of questions. We had a lot of inquiries about what's coming up, and we're also working with OEMs now that have come to us. So one example, I think some of you know that we have a fairly large program with Weichai Power in China. They're also into mining equipment, so now we're looking into rolling out a first pilot where we're looking at doing a 154-ton truck that's going to be equipped with 300 kilowatts of fuel cell power. So again, this is just sort of early stage. We're also in the process of learning about what's happening for this specific application, but I think we're picking up momentum here, and I think that over the next little while, we're going to do our pilot, we're going to learn from it, and we're going to try to work with different OEMs to expand on that.
I just would like to add that, and maybe many people in the room don't know this yet, but actually these mining trucks, at least the one with electrical drive, they are already electric vehicles, and I like to make a small joke about it. Today they have a diesel battery, because they didn't find a way to put sufficient power on board. And actually the combination of hydrogen with battery technology can provide us this solution.
Thank you. And Jan, what's your thoughts on your dealings with OEMs?
Frankly, in my job I deal fairly little with OEMs. but what I understand from our tech guys is, and as has been established earlier, it's not like there is anything on the shelf at the moment in that space, which means it'll take time for it to be developed. I think that's obviously a challenge in many ways, because there seems to be momentum now. and a lot of interest, and hopefully that can be followed up by delivery, right? Because otherwise interest may turn into less interest over time if you don't have a tangible solution or something that you can concretely work on. But I think what I do understand is that those conversations are actually happening, and I think there is both a push from the customer side, from us, and there is also a pull from the OEM side in terms of trying to work on that. Maybe just one quick point on the safety side, which is obviously the top priority in any mining operation. But hydrogen does not only come highly pressurized and or in highly pressurized form and cooled. But you have LOHC, liquid organic hydrogen carrier liquids, which could be used actually in underground operations. For example, we have invested through our venture capital fund in a company that is actually offering that technology. So I think we also need to open our own thinking in terms of what the available options from a technology side are. Obviously, again, as we said earlier, there is a cost issue potentially, and there is do they then actually in that form deliver the necessary power that is required? But those are technical challenges that need to be addressed.
You've had some experience clearly with the forklift, but what about OEMs when you're scaling up to larger size?
So it all depends on your relationship between, from OEM to OEM. You do get those who come fully on board and it's, okay, let's go, what will work, what doesn't work. But unfortunately, you do get other OEMs who say, this is our product, we're not prepared to change anything, and you take it as it is. And it's for you to try and work together and see what is the best fit. And if I can use an example of an LHD, for example, it is a specific piece of kit that operates in deep level mining. On our particular mine, it is ultra low profile, so it basically stands, if I had to stand, or probably as high as this couch. It's very, very compact. And when you are dealing with OEMs and you are looking at a fuel cell system and you do need to integrate some battery within that, you've got limited space. Who's willing to actually share that information from an LHD manufacturer's perspective with the fuel cell and the battery manufacturers? And from their side, are they prepared to reconfigure the size of their units? Others tell you it's a standard operation, this is what we use elsewhere, and this is all you can get with it. Whereas you do get other OEMs who come on board and say, well, we could accommodate it in this way so that it can be a plug and play. You can take my system and you can put them into a rack and you can get 4 across, 3 down, and that will give you your power requirements that you need, and it will fit into, we'll make sure that it fits into the structure of the actual vehicle. So it all depends on that relationship that you build and how willing everyone is to give a little, because we all have to, in these developments, give in a little.
I would just like to add on the OEMs, I think there's 2 topics. So one topic is really at the OEM side is where we have this IP issue. And so them opening up and to collaborate on finding an accelerated solution for the hydrogen one, because they see it, maybe some of them are working on it, we don't know. And they want to be the first mover on this one, the same as Komatsu did with the electrical drive, which was a big win for them. Maybe within 2 years, let's hope, somebody comes out with a hydrogen version. And then on the other side, I actually forgot. I'll come back to you in a second.
That's okay. I'm quite interested in this one because, which is a bit about the lessons that you've learned in testing, right? In particular, because I think, Oda, you talked about the challenge of skills and maintainers, right? And if we're in Kalgoorlie, there aren't that too many PhDs, right, out on my mine site to come and fix my truck when it breaks down, or in the Pilbara, Jan, you also mentioned that hydrogen is complex, right? And in operations where you're using it in your processing facility already, understand that and you have a familiarity with it. Once you take it into the mobile equipment fleet space, there's a different operating culture. So, but then to counter that, I think we all realise that the future of mining is complex. Automation brings complexity, and we're already facing skills challenges in just maintaining a more technically advanced mining fleet. So how do you see from your lessons learned and from your work so far, how do you think that will play out with the introduction of hydrogen?
So if I took our forklift project in particular, like I said, I think concerted effort has to be put into developing the technicians within the country. So proper educational programs through our technical colleges, not necessarily the universities, that look at the hands-on expertise and to be able to develop that. And it's not very difficult to take, if I have a diesel mechanic, I could, through a structured program, get him au fait with what can be done. Yes, I'm going to need a PhD student and someone with that kind of acumen when it's going to come to designing a system and how do we integrate it together. But if all I'm going to do is dismantle bolts, get access to a cooling pump, take it out and replace another cooling pump, why do I need a PhD student to do that? How do I train people up correctly to be able to do exactly the same thing? Yes, I understand if it comes to the fuel cell stack and there's a problem, I can't, except for maybe asking the person to take it out, I can't expect them to dismantle that and tell me exactly which particular area or MEA is not operating efficiently and should I go and replace that particular membrane or buy me a whole new stack, So we need to manage our expectations of people and develop them according to what is required for the job.
Thank you. And perhaps from your perspective about lessons learned and skills support from I suppose a provider or supporting of the technology, how do you see your role?
You mean on the skill of the people that will work on it?
Yes. Yeah, and supporting the introduction.
Okay. So I think on this side, I think probably once we change from combustion engine to fuel cell and battery, actually one of the advantages that we will have less maintenance. So we will need normally less people in this area working on it, and then of course we have to see that they are properly skilled. But if I can take an example where we have seen a successful retrofit going on, which is the forklift actually, if we look at the United States and some other countries, we have companies like Plug Power, Ballard, who have developed actually retrofitted stacks. And this was the point I wanted to make before, which I forgot, is that the question is to which extent do we need the OEM? Because if we look at the many thousands of forklift trucks that are running out there today, which have a very high demand on productivity level, very similar to the mines, this is happening without them. Of course, they provide equipment, but the retrofit is done by an external company. And these external companies, they have the capabilities to bring the skill set that we need as well. So it's either a retrofit with an external company, or it's the OEM, which is building the equipment, that can bring it on board. Because in the end, if we look at a Komatsu truck, if we break it down into components, you will find GE, you will find Siemens, and many other technology providers.
Yeah, thank you. Alfred, have you got anything you'd like to add?
Yeah, I mean, we have limited experience in this area, but I mean, from a mining perspective, but if you want to just draw from other industries, I think for us it's really about providing a seamless experience, for customers, and it's really about taking what we've learned in other industries in terms of scaling up, and about the service infrastructure, and as well as working with companies downstream from us to really help maintain these vehicles. So from a manufacturer perspective, our plan is really to do the same as what we've done with other industry and have made that successful.
Thank you. Jan, let's move on to show me the money. Right. So What factors do need to be present to support the business case for hydrofuel mobile? So what factors do you believe have to be in place to support the business case?
Well, I think we said earlier on, safety is the number one concern. Then we also mentioned earlier on the supply chain and a redundant supply chain. So not just having one option with a supplier. There is clearly the question of the cost. Having said that, I think we've heard earlier today, not only on the capex side, that things are coming down in terms of electricity costs from renewables, but also the actual electrolyzer costs are on a very good trajectory, and that's where. And we made that clear when we announced this. We're not necessarily looking at the moment at a better MPV, but projects to wash their face, as Tony said when he spoke about it. Because I think what we also need to keep in mind is that regardless of price fluctuation on diesel, etc., but we have indication that carbon is not going to be freer or cheaper than it is now, and so it's something that is coming, and if you're forward looking in that space, obviously you take that on board. Plus, I mean, Rio is the best example with Euro Green aluminum, right? There may actually be something, given that consumers are more and more interested in not only the product they buy, but also where it comes from and how the products that go into their products are actually being produced. This is something that is going to be asked, and if we can do carbon-free platinum or whatever it is. You may not get more money for it, but you may actually be able to sell it.
Yes, yeah, that's it. I agree with that. And for me, I was interested in the economics for your LHD, right? In comparison, 5% more cost, higher cost. Actually, sort of thinking about that, given, yes, we'd like our projects to wash their face, but we've also got a challenge of reducing our carbon emissions within a time frame which is challenging. So 5% doesn't sound too bad. But what are your thoughts on
I agree. 5% is not too bad, but that wasn't the major factor for the project not going ahead. It was availability of actual capital funds to do the project at the time when we announced major retrenchments in the market. So we couldn't be seen as, going off and doing something that a highly unionized workforce could look at and say we're being irresponsible with spend. So that wasn't the only case. And like I said to you, a major driver was around safety underground and the change management around that. So it's still something that we are working on, and hopefully we'll get to the point where we can push the project forward. I have to say as well, when we looked at the 8 megawatt project, we did it from a point that we understood that the project would cost us more at the onset. And when we looked at building the financial model, that was exactly what happened for the first 5 years of the project. It was going to cost us more than the energy grid. And based on certain assumptions, this was going to taper down as long as the project proved NPV neutral over the 20 years. And it eventually showed a cost saving, even if it was towards the tapering end of the project, we would consider it. However, the energy prices in South Africa didn't escalate at the point that we assumed, and if anything, it made the NPV grossly negative, and that's why we couldn't look at it. So a 5% is something that is looked at over the life of equipment.
Sort of have about 10 minutes at most. Can we see if there's questions?
Yes, absolutely. It's a good point. A good time to move to the audience. for people interested in costs.
Oh, really? Can we try this?
Thank you very much. Louis Kent from BHP. I just had a question following on from Jan's truck you're putting it on, what kind of payload, things like that, just to understand whether it's expected to achieve similar results to existing trucks, or whether you're making some trade-offs at this early stage that you might be able to reduce over time.
I'm too bad the mic isn't working. I'm afraid I can't share too much because it's currently still ongoing. It's under negotiation, etc. But I mean, you look at the drawing, you can see that it's a rather big truck in the 300-ton range, and I think that's what I can say at the moment.
I think if I may add to this, we have run some general simulations, and of course productivity and lowering costs for the mining sector is the most important. This is what we have to aim for. What we see in our simulations is that productivity will be higher with the hydrogen battery combination vehicle. So you will gain on this. And the point I wanted to make before is that when we speak about comparison for fuel prices, we have to be careful, because we are not aiming to getting a fossil parity, as they call it. We don't need to be at the same price at the energy level. What is important is that we are better at a TCO level, so total cost of ownership of operation, because there are so many other advantages that you get by switching to hydrogen, which are not always taken into account. So.
Attilio Pigneri from HU. I guess it's a question for Jan and then more generally to the panel. Obviously, you can't share that much in terms of the cost of the specs, but how much of the project is also about the fueling protocol? It's really about a very significant amount of hydrogen to be transferred on board within a time frame that fits the operating requirement. Is something you're covering at this point, or are you really focusing on delivering the first truck?
Do you know what? I simply don't know. I can. If you're really interested in that, I can put you in touch with my respective colleague. I don't know if you have any general ideas on that.
Yeah, I can comment generally on this one. So I think, as I understood from Jan's presentation, the idea is to have a proof of concept, to have what we like to call a minimum valuable product. So I don't know exactly how much kilograms of hydrogen will be on it. If we take a relevant equivalent to what the diesel is today, you should be taking in the range of 800 to 1 ton of hydrogen, which is a lot. Looking at the existing protocols for recharging, there are some gray areas, which doesn't mean it's not possible. Of course, we will have to make a protocol for this. There's some companies working on it for the truck. For the mining truck, it would be even a little bit bigger. And we should maybe be thinking about multiple charging points, very similar to what Tesla has done for their batteries. So you don't charge the 800 as a whole system, but you have separate systems. I don't know if this is clear, but there's a lot of work to be done in this area, for sure.
We'll take one time.
It's Gordon Weiss from Energetics. Fascinating points that you've raised. Now, one thing that I'm thinking about is that we're now 31 years before the world was supposed to become carbon neutral, and that's the lifetime of many new mines that are being considered now, and maybe only a couple of capital stock turnovers. So, what do our miners do now? What message do they send to the investment community and their owners about what will be the cost of either running a mine or the higher cost of producing their products in a carbon constrained world?
I'm certainly not qualified to answer that.
You're on the panel as well.
So what would you like to say?
So I think what I alluded to our sustainable mining plan, right, which is certainly looking at that, and that's not just, I mean, this is not just a hydrogen question. It looks at how coming from water footprint to the energy and carbon footprint. So there is a number of things that we're looking at from a technology innovation perspective. Hydrogen possibly being one of them. But it's a conversation that we're having with the investor community very much, and as we all know, we're actually getting a lot of pressure in that space, and that ranges from requests for divesting to actually what is your scope 1, 2, 3 footprint, to using more renewables, etc., etc. So I don't know if I can give you a very straightforward answer, but it is very much on our mind. And I think if you look at a lot of the way executives will talk about their approach to mining, it plays a very important role in not only planning for future projects, but also looking at what do you do with your existing projects, which may have been designed under a very different, for a very different environment. And that's certainly something that we're grappling with as well, as to how we lower our carbon and other pollutants footprint in those operations.
I will risk myself as an outsider to the mining. So of course Engie is not a mining company, but we've been looking at the sector. When we speak about end of life of a mine, as far as I understand, it's not necessarily that the resource is depleted, it's just that we cannot extract it in an efficient way and be competitive on the market. So I think the plan of Anglo American to reimagine mining, and from many other mining companies, actually this is to see how can we keep this end of life, or how can we maybe extend the end of life of the mine. And if we don't do this, then either because of climate regulation, or the fact that things get too expensive with fossil fuels, actually the end of life will be a lot sooner than you were expecting today.
Thank you very much. Yes, that's right. Thank you.
Please join me in thanking our panel.